Hello everyone. I'm going to do a short video on the ARKit changes that we've added to Godot. One thing that is important to realize is that in order to use ARKit, you need to use iOS 11 and you need to be on Xcode 9, which closes off Godot to older phones like an iPhone 5. So don't expect these changes to be applied to master anytime soon. ARKit support officially will probably not be added to Godot until 3.1 or something like that, depending on what the decision on this is going to be. So the only way to get this working right now is to actually download the source code and compile from source. And the easiest way for that is to go to my own fork of the Godot project, where there is an ARKit branch that you can clone and then compile. I'll try and keep the ARKit branch up to date with the latest master as things get fixed and improved in Godot 3. But don't expect this to be in the master anytime soon. This is the only way to get this to work at this point in time. I'll put the link down in the video description. The other link which is interesting to have is this one, which is an ARKit test project that I've got on my GitHub page that you can download. This is basically a more further along version of what I'm going to show in this video today. So have a look at it. It does a little bit more. It goes into a little bit more detail, and I will be enhancing this as time goes by to try and do more things with this. But for this video, I'm just going to keep it relatively short, just showing you how to set up ARKit in Godot. A lot of the information actually will apply to setting up VR as well in Godot once we start getting or taking a look at that. But for now, this video is just an introduction in getting started with ARKit. So in Godot, I have created a brand new empty project, and we need to start off with doing a little bit of configuration to get everything up and running. So let's start by creating the scene that we need in order to make everything work. Just for structure's sake, I always add a main spatial node as a root node to my whole tree. So that's what we start with. But then the first thing that we need, which is new, and you can actually see this when you search for the keyword AR/VR. There are a couple of new nodes added to Godot, which are part of the core logic that we've added into Godot to support AR and VR. And the first one that we really need to add is this AR/VR origin. Now, the AR/VR origin is a spatial point within your game that maps to a real-world location that the tracking system relates everything to that is being tracked. For ARKit, that is basically a starting position of where your phone is when ARKit gets turned on, and everything is in relation to that point. But you'll see once we start looking at VR, there's a little bit more to it than just that. For our demo today, it is enough to just drop that in there, and we don't have to really worry much about setting this up. It'll work straight out of the box. The second thing that we need, obviously, is a camera. Now, we've got a special type of camera for VR, which is the AR/VR camera. This is just a subclass of the normal camera that we find in Godot, but it ties into the AR and VR system, and it is automatically tracked. So again, with ARKit, the origin is your starting point, but as you move your phone around through the real world, the location of your camera is tracked against the origin point, and that is automatically updating this node in your scene, which is kind of handy. The other thing is, although we have these standard options inherited from the normal camera in Godot, most of these settings are actually going to be ignored. they are simply going to be taken from the phone itself. The phone will dictate, or the ARKit framework will dictate how the camera is set up to match exactly with the live feed that we're going to get from the real back camera on the phone. We don't actually need to set up much more than that at this point in time. We'll come back to the AR VR camera in a minute, but for now, I'm just going to leave it at that. Okay. I also want to have something that we can actually see, because right now we're just going to have our camera feed, and we're not actually going to see anything on screen rendered by Godot. So I'm just going to add in a mesh instance here, just something that we can make visible. So we'll just do a little cube. There we go. There's a cube. I'm going to be moving that outwards a little bit. Well, we can use the default material, that's fine. And at this time, it is important to have a talk about the sizing of things. Our default cube mesh has a size of 222, which for when you make games is pretty nice if you use that sort of scaling. As long as everything is properly scaled relative to each other, that'll work. But in AR and to some extent VR, the measurements are much more critical, because we are rendering in relation to with AR to real world objects. In VR, we are rendering to how your stereoscopic view is projecting things or is seeing things. And as a result, most of these frameworks, including ARKit, handle or have a real world measuring as far as the sizing of virtual objects is concerned. And in this case, a cube with a size of 2 by 2 by 2 will actually end up looking like an object in your real world with a size of 2 meters by 2 meters by 2 meters, which is a little bit overdone for what we're trying to do right now. So we're going to make that a bit smaller, and we're going to make this a cube that is approximately, actually I'm going to make it 10 centimeters just to begin with, or else it'll be really big, which means I can move it a bit closer again. Okay. What we obviously also need is some lighting in our scene. Now, ARKit obviously tries to do some real-world lighting, to which we currently don't really have much access. So I am just going to leave that as a pretty default sun, just so that our little cube is lighted properly. And in the end, that's something where we still need to do some improvements. At this point in time, as far as I'm aware, ARKit just gives us a general lighting information, just the strength of the lighting of the room that you're in. But I don't think it actually tries to interpret the direction that the main light would come from. I'm not even sure if it could do that. So yeah, a default sunlight like that is all that we can do to start with. All right, the last thing in our scene that we need to do is actually go back to our AR VR camera, because we need to set up our environment. So we're going to create a new environment here, and we're going to have to look at our background. And here's a new option that was added to Godot, which is the camera feed option. Now with ARKit, or actually with your phone, you have your camera feed from ARKit, you have the native camera feed from your back camera, and you have the camera feed from your front-facing camera on your phone. So basically, the camera system or the camera feed system that we introduced in Godot will allow you to use 3 different feeds. We've made sure that if ARKit is enabled, it is always the first feed that is active, that you need to use in order to show the camera image. So simply doing that, selecting a camera feed, making sure a camera feed is set to 1, that's enough to make the image work. There is a horizontal and vertical flip option. The vertical flip needs to be on because the standard TV format is always reversed from what we do in 3D rendering. The horizontal feed you would flip if you would be using your front-facing camera for things, but we're using our back-facing camera, so we're just gonna leave those on the default. I'm not going to bother with any of the other environment settings at this point in time. This should be enough for to do what we need to do to start with. The last thing that we need to do before we can test our very first little scene is create a little script. There we go, on our main node. And all we're going to do here is actually initialize the ARKit system. And this is something that that is part of the AR/VR system, because obviously when you're designing your application, Godot doesn't know that you're going to deploy this as an application that potentially uses AR or VR as output. And by default, AR or VR is not turned on. You actually need to turn on the system that you want to use for rendering your game in this case. And that's actually a really simple thing to do. We simply go to our AR/VR server and we call find interface on that. And we're going to find, in this case, our ARKit interface. So the AR/VR server exposes multiple interfaces to your game. The interfaces that will be available will be different depending on the capabilities of the platform that you're on. So for our iPhone, it'll just be the ARKit, but for our desktop, we might have access to OpenVR or to Oculus SDK or any of the other frameworks that we're working on implementing. If you know for which interface you want to create your game, so in this case we are creating something purely for ARKit, we hard code it in the way that's shown here. But obviously, if you don't, the AR/VR server has got an interface for letting you know which interfaces are available, and you can give that that option to the end user. We obviously want to make sure that we have the interface. So if we run this on our desktop, ARV server will not find the ARKit interface. It'll return nil, and obviously we need to make sure that we don't try and continue with that. And finally, in order for this to work, we need to initialize our ARKit. And again, it will return false or true depending on whether it's successfully initialized. In ARKit, there's not really a reason why it wouldn't initialize unless you're working on an older phone. But yeah, and the final thing that we need to do, sorry, that was my son who almost came in. The final thing that we need to do is to actually tell the viewport that we're using that it needs to do all the AR stuff that we need to do. And in this case, we're doing that on our main viewport. So we're simply going to set this little flag AR/VR on that viewport on. Now with ARKit, and if we end up doing AR Core, you have to use the main viewport. And for a number of other platforms, you have to do the main viewport because, you know, like just look at mobile VR, for instance, where you're rendering to the device itself, to your phone itself. You will be rendering the AR/VR system to the main viewport. But for some of the other systems, like when you have a separate HMD, you can actually use the main viewport, the main interface, for something completely separate from your VR rendering. But in 9 out of 10 cases, these couple of lines of code is what you will need to make the system work. So finding the interface that you want to use, making sure that that was found, initializing that interface, and then if that's successful, telling your viewport that, yep, that is what it is that we are using. Okay, let's save our scene. And let's set up our project as well. So we need to be over here and say, let's go select that one. And now we need to export this to our phone. Add our iOS export. Now, I'm not going to do the whole export project. I'm just going to export the package file to my beautiful little iOS thingy here. There we go. And I'm going into my Xcode that I prepared earlier. Make sure that my phone is selected. Let's see if that will start. There we go. And there is our little block, which is quite far away into my wall, which is why this looks a little bit weird. You might have noticed when I started moving my phone, the block sort of stayed in position in the center of the screen, while now it is moving along. And that was because ARKit wasn't actually doing any tracking yet. It needs you to move the phone around a little bit before it figures out, like, oh, look at that. There's that's where the world is, and that is how I'm tracking. Also notice the frame rate is a bit slow on the capture. That is purely the capture. It's actually quite solid on my phone. All right. So now the thing is, having our little cube just floating around, well, my wall would have been somewhere over there, and the cube sitting quite far into the wall. What we really want to do is we want to be able to place our little cube somewhere in the real world, and for that we need to know a little bit about our real world. ARKit has this thing called plane detection, where it's continuously scanning the image to see if there's any flat surfaces that it can recognize. And once it recognizes a flat surface, it'll create what is called an anchor point. And that anchor point basically represents the center of that surface and has some sizing information about that surface. And ARKit will continuously update that anchor as it learns more about the surface. So if, for instance, it's a very large table that is recognized, but the camera was only having a quarter of the table in view when it recognizes the table, it will not have recognized the size of that table properly. And as it learns more about the view around it, obviously, it is going to adjust that. So let's make that bit work in Godot. For that, we also have a new node that we can use, which is the ARVR anchor node. Now for this, it is important to know that obviously we are just creating an anchor point right now in our interface that will be linked to the very first anchor point that ARKit finds. So you can see that we've given that an ID. So that's our ID 1. That's the very first anchor point that ARKit will find, and it will use that anchor point. As there are more anchor points that ARKit finds as you move around your room, and there's other surfaces that ARKit identifies, obviously you need more anchor points. Now for our demo, we're purely going to fix this one anchor point in place, and we're going to be using this singular anchor point. But obviously Godot will be receiving signals as other anchor points are recognized, and you can react to those and make those visible or create new nodes or whatever you think is right for your environment. We're going to create a small little helper script on our anchor point. No, let's call it anchor. And all that we're going to do here is we're going to create a process. And all that we're going to do in this process is change whether our anchor point is visible, depending on whether this is an active anchor point. So this anchor point is linked to the first anchor point that ARKit will find. As long as there is no anchor point yet, as long as ARKit hasn't found an anchor point yet, get is active will return false and will make that invisible. Now obviously the anchor point itself doesn't render anything, so we're going to add a child instance here just so that we can make that visible. And for that, we are just going to use a plane mesh. All right. Now, as soon as our game starts, that plane will be hidden. I'm going to make it slightly smaller, by the way, because that is a really big plane. There we go. And as soon as the plane is recognized, our anchor will be placed on that plane. Our anchor point will become visible and we should see our plane. Now the last thing that we need to do in order to make this work is tell ARKit that it actually needs to start searching for those anchor points. So there is a property on our ARKit. AR is anchor detection enabled, and we simply need to set that as true. Now, the thing to realize with anchor detection, with plane detection, we call it anchor detection in the main Godot structure just to be more ambiguous for other platforms. But internally for ARKit, it's plane detection that is being enabled in here. The thing to realize is that it's quite CPU intensive to scan the interface or what the camera sees and try to figure out what the planes in the real world are. So generally speaking, what you would do is once you find one, you would turn this off, or you would only keep this on for a limited amount of time, or you might make it a toggle for the user to toggle. You don't really want this to be continuously running. Once you've positioned things in your world, the anchor detection, the plane detection, isn't really that relevant for most games anymore. So that is also why it's off by default. But yeah, so we have that enabled. We have our anchor point. We have our plane to make it visible. So let's see if the system indeed lets us find anchor points. So we're going to do the same thing again. Export that out. And start that up. Let's make sure my phone's up and running. Sorry about the mess on my table, by the way. This is a desk my daughter usually uses for her homework. All right, so let's see if it will recognize my desk at some point in time. All right, there we go. So it's actually recognized part of my laptop as the center point for the plane, but that's good enough for me. So our little cube is still there off in the distance. So the last thing that we'll do is, now that we've got our plane detected, is actually use that to position our cube, and we're going to do that with a little bit of user interaction. Right. Okay. Now for this, I am going to cheat because this is quite a bit more code than I care to remember. So I am just going to copy that from something I prepared earlier, and then we're going to change that over. You can see that this is coming from my my ARKit demo app. There we go. We should have really renamed that cube or something. But anyway, just to explain this little bit of code. First of all, I'm going to start by making our cube invisible until we decide where we want to place it. We actually don't want it visible in our scene. All that we're going to do here is, first of all, we're going to get an object that points to our anchor point that we have in our scene. It's then going to check is our event, because our input event here is capturing all our events, whether it's keyboard events or mouse events. Of course, with the phone, that means touch events. So it's going to see, is this actually a mouse button event, which on a phone is a touch event, whether it means that we're touching something, it's pressing down, and whether our anchor point is active. Have we actually found our anchor? We don't want to do anything until we actually have an anchor point. We're then going to go grab our camera, and we're going to use the project ray origin and project ray normal functions that exist on the camera to get the location of a camera and to get a ray pointing into our scene based on the location where we have pressed on the screen. And then we define a plane, and that plane is a mathematical representation of basically the plane that we're rendering here, but extending to infinity. So basically we're saying, you know, in the plane, in the area represented by our anchor, we want to intersect or test where the ray being shot out of our you know, the point that we press with our finger, the ray from the camera shooting out into the world. We want to see where that intersects with that plane, and that gives us a real world location, exactly where we're basically pointing at on our table. And all we're doing is, once we find one of those, we are moving our little cube to that location, and we're making our little cube visible. Now, seeing the center of our cube is actually in the middle of the cube, this is going to make our cube go halfway through the table, which will look interesting probably. But it is just to get us started. We could probably add a little bit of height to that to counter that, but for our little demo here, I just want to show the basics and you know, leave it up to you guys to make something far more interesting than what I'm doing right now. Okay, so we've exported that again. Let's get that onto our phone again. Come on, there we go. Takes a moment to boot up, but there we go. There is our... And again, you know, this is actually running at about 60 frames per second on my phone. It's just the screen capture that is slowing down. There is our plane. It's actually that slow. And let's see if our tab works. Nope. I did something wrong. Let's find out where I made a mistake. Okay, so it became visible. So where am I going wrong with this? Well, let's put a breakpoint there and see if we can find out whether it all makes sense. Oh. It does not help running it on the desktop. No, cube is not seen yet. Oh. I must have skipped a step because it is working just beautifully. So I'm just tapping on the screen, and every time where I tap, my cube appears. Now notice, like I said, it's going halfway through our little plane. Now obviously it is not cutting the bottom of the cube, so that'll kind of look like we're halfway inside of our table. Yeah, there we go. Now, just in case you're wondering, in our code we are placing the cube in our scene at the location where we intersect with our plane. We're not actually making it a child object of our anchor point. And the reason for that is that while it's actually surprisingly stable at the moment, like I mentioned, ARKit will continuously try and readjust the location of our plane as it learns more about the world. And if you make your object a child object of the anchor point, then obviously you end up with your object continuously moving through your scene. Anyways, yeah, that's that is ARKit in a nutshell. Again, you know, obviously we're just moving a cube around. It's not that spectacular, but all the ingredients for making something with ARKit are there. So yeah, that's all that I wanted to show for today.